Hello, and welcome to the latest episode of the Gradient Podcast. We interview various people who research, build, or use AI, including academics, engineers, artists, entrepreneurs, and more. I'm your host, Andrey Kurenkov. In this episode, I'm excited to be interviewing Chip Huyen. Chip Huyen is a co-founder of Claypot AI, a platform for real-time machine learning. Previously, she was with Snorkel AI and NVIDIA. She teaches CS329S, Machine Learning System Design at Stanford. She has also written 4 best-selling Vietnamese books, and more recently, her new book, which is O'Reilly's Designing Machine Learning Systems, has just come out. She also has a Discord server related to this stuff, so we'll link to that below. But with all that being said, thanks, Chip, for joining us for this interview.
Hey there. I guess I'm very excited to be here, and I think it's a good excuse for me to catch up with Andrey. It's long overdue.
Indeed. We met at Stanford, where I also am a grad student, or still am, with Chip having long since left. But back in the day, we did meet each other in an AI-themed CS class. So knowing Chip, I know this will be a really fun interview. So let's get into it. Usually we start by asking people how they got into AI, how they started doing research. But I think before that, in this case, I'll ask about when you were in high school, you went to Brunei for a 3-day vacation, which turned into a 3-year trip for Asia, Africa, and South America, which is listed in your personal website.
I used to be cool. Yeah.
Yeah, I know. What happened?
I know. So actually I met a friend back then. So I met him when I was traveling, and he came to visit me in the US, and he was like, Chip, you were way cooler when you were 20. I was like, okay, that's sad, but okay.
Yeah. Well, so how did that happen? How did a 3-day vacation turn into a 3-year journey across the world?
You know, when you're young, you just have the desire to want to see the world. So I think I already had that feeling. I guess I came from I grew up in a very small village. So nobody in my family has ever traveled outside the country. So I was like, okay, what is out there? So I went to Brunei, and I met a lady at a festival, and she was like, I'm driving to Malaysia tomorrow. Wanna hitch a ride? I was like, yeah, sure. So that's what I did. And I thought it was really easy to just hop from one country to the next. So let's just go to see how far I could go. So that's what I did. And I started writing and picking up odd jobs on the road.
Yeah. Wow. And you managed to make it for 3 years. So what convinced you to go back and live a, normal-ish life after all that travel?
So it sounds like very exciting looking at. I'm not sure it sounds exciting to other people. I used to think of traveling the world is very exciting, but then things get old. So you meet a lot of people, but you never really develop deep connections because you're always on the move. So it did get old, and I wanted something more. So also in a lot of conversations, I started realizing a lot of gaps in my knowledge because I just finished high school. So I wanted to learn. That's why I went back to school.
I see. And I suppose that's when you started getting into AI, I would assume at Stanford.
Yeah, so I didn't think I would study AI. I didn't know what AI was. But so I went to college, thinking I would do creative writing.
Mm-hmm.
So my friend actually told me, it's like, you want to be so poor. I was like, I love writing. So I went to Stanford, and it was, as at Stanford, you had to take some fundamental engineering fundamental. So I took the CS course, and everyone told me that you should take it as early as possible when all the friends are still doing it, or it'd be very painful. So I did. I took an intro to CS first quarter, and I really like it. I think I was very lucky to take a course with Mehran Sahami, and he's an amazing professor. He makes the course so engaging, so fun. And I just realized the importance of having a good teacher, because he totally turned me from someone who has zero interest in engineering become like a CS major.
And then it all just sort of followed from there. And actually, I'm curious, when you were an undergrad, so you started, I think, what, 2015, 2016-ish?
14, yeah.
14, okay, yeah. So you started kind of as the deep learning hype wave was just like accelerating and still not at the speed.
Nowadays,
Yeah. So at what point did you get the idea to create your own course, which is TensorFlow for Deep Learning Research, which you actually developed and taught in undergrad?
So it was never really an idea. So in my sophomore summer, I did an internship with a startup. It's like Primer, and I learned TensorFlow there. I thought it was really cool because I was able to just like build a model like very easily. And I wanted to do more. So I was looking up tutorials on TensorFlow. And there was not a lot. Or like there were some, but like very hard. I was very lucky. I had a very good mentor at Primer. And he walked me through the stuff. It was like, what is it going to be like without him? Now I want to go back to campus and I want to have a group. I want to have a mentor. So I went to some of my professors like, hey, can you like teach a course on TensorFlow? And they were like, I don't have time for it. So nobody wanted to create a course. And someone's like, why don't you just do it? Because there's a thing called student initiated course. And I was like, okay, this sounds reasonable. So that's how I started. And I emailed a bunch of people whose tutorial I found to be really good that I like, and I got a lot of help from them.
Okay, and then the course was apparently, a success because it happened twice. So it didn't. A lot of people signed up, right?
A lot of people said TensorFlow was such a hot keyword back in 2016. So I think the course got at the right time because it was. I think TensorFlow was out in like late 2015, and my course was offered like at the end of my 2016. So it was pretty fast for a new public tool. So I think it was just at the right time, and I got a lot of help from people. Yeah. But I did learn a painful lesson. So I think I created a course on TensorFlow, and then TensorFlow decided to upgrade to 2.0. And all the tutorials I created was just like outdated. And then people were asking me, hey, do you want to take your course again? And I was looking at it like, no, I had to like recreate like 80% of it. So that's when I realized like, how ephemeral tools are. Like anything that like, if you create anything that's like timely, is going to go out of like fashion very fast. And we don't want to like over-index on any particular tool because tools come in and out of style. So I think that's a lesson I learned for my next course. So we want to focus on something more fundamental, and also the same for my book.
Exactly, yeah, and we'll get to that in due time. Your course and book, both about machine learning systems. So, but yeah, jumping back a bit, I guess, obviously you took some classes at Stanford about AI, which are, at this point, were, really cool classes. But yeah, looking back, would you say you were immediately enamored by AI, or is it just like a thing that built as an interest over time?
I thought AI was really cool. So I think it really comes down to having the right teacher, because the next course I took was CS 221. And at the time, we were learning some algorithms to like play Pac-Man. So they just like having some AI to
This is intro to AI, yeah.
Yeah. I thought it was like super fun. And I found myself really enjoying it. And I think I apply the same algorithm to like other games, like Ghost. Then what really, really convinced me was when I saw the news on Google Translate. So like around 2016, Google Translate announced they apply their big language. I think they didn't call it language model back then.
Seek to seek.
Yeah.
Back in the day,
improve the quality of translations. And I'm from Vietnam, and like my family doesn't speak English. Like my brother doesn't speak English. So, and I just realized it's like my parents didn't want to visit me in the US because they just was afraid of like traveling, because they didn't know like how to communicate with other people in different languages. And my brother like can't really read things I write in English. And I just realized it's like having a good translation systems can really eliminate a lot of the language barrier. And I think it would be and really, really powerful. So that's what convinced me about the power of the potential of AI. I don't want to say the power of AI, but the potential of AI. So when I first got into AI, I actually focused on machine translation.
Oh, wow. That's a cool story. I remember, Intro to AI when I took it at Georgia Tech as an undergrad. Yeah, I thought it was all really, really cool. And actually, at the end of the course, we had one class that was just the teacher, the professor, kind of going through her own research. And I thought it was really cool. And then based on that, essentially wound up applying to do a summer research internship and then to do research with her. So, it's interesting how one class can do that.
I know. I guess I think a lot of professors I had the fortune to study with really inspire me to want to teach more.
And you get to inspire people as a teacher as well, so that's pretty cool.
Well, I'm not sure. That's a plan, right? But whether it actually got to inspire anyone is up to people to decide.
Yeah, exactly. You can't plan for that. It just has to happen. And I obviously dug through your whole website and preparation materials for this. Even though I know you well, I gotta dig up something from your past. So I found it interesting to come across this blog post, "Confession of a So-Called AI Expert," which I remember seeing
blog post. Yeah,
back in the day. Yeah, exactly. Yeah. I went all the way back. And it's all about how, having this course and some Stanford classes and whatever, now you were seen by many people as being a so-called AI expert. But at the same time, you felt this was kind of overblown and that you're basically a beneficiary of this AI hype craze. So looking back, I guess, can you recall your thinking at the time when you decided to write this blog post and how that has evolved since?
Wow, it was an old blog post.
5-6 years. You have to remember what it was to be a younger version of yourself.
Yeah, naive. So at the time, I think I was a little bit insecure. I think I was a junior in college, and I did see something was really strange. So I come from a writing background, and in my first year looking for internship, everyone, like a lot of recruiters, just look at me like I'm crazy. They were like, "We can't take you seriously as an engineer if all you have done is writing." So it's actually made me very scared. So I actually didn't talk to people about my writing. I just only started to talk. Oh yes, I did write books before. Like very recently, I had a roommate who lived with me for 3 years in college, and she didn't know that I wrote books before until I graduated. So that really made me scared because recruiters really told me that. So and then I just saw that I got rejected for every internship I applied in my first year, and then I taught the course, and then several companies who rejected me previously reached out to me and say, "Hey, how are you? Are you interested this year?" So it's just a bit crazy to me. It's I didn't change as much. Of course, I learned a lot of new things, but my knowledge didn't really have the depth of it yet. So there was something off here, and I did really believe in the potential of AI. I just thought that just because of the hype, people didn't really have time to think about what is really important to know, and just relied on very weak signals, having a course. Even though TensorFlow tutorial is not the same as having a course on the, I don't know, theory AI or something, but people still conflated those signals.
Yeah, that makes sense. Back then things were just happening so fast and growing so fast. I guess people just, any somewhat promising signal was good enough.
But the golden days are over.
Yeah, not anymore. The
job market is so much more competitive now.
Yeah, everyone got into AI. All the undergrads graduated like you, and yeah.
Did you interview Shreya on the podcast yet?
Not yet.
Oh, she was saying just like, oh my God, like, if she was doing her undergrad again today, she would get into Web3 because like AI is too much.
I don't know if I would still do AI personally, but at least we're not going to get another AI winter based on the seemingly AI actually being helpful. So that's good.
Things are changing though, because I think like when I got into AI, people were very excited about chatbots. And at that time, I didn't really have good models for chatbot yet. But it seems like we are getting there somehow. It just took a while.
Yeah, I think it's an interesting time where, a decade ago there was a lot of excitement, and now there's some applications where, AI and deep learning are generating billions of dollars, like Google Translation, but there are still a lot of emerging things that are in early stages but seem very promising. So it's kind of a mix of a lot of things are in early stages and a lot of people are still exploring them. And that makes me ask, so you did some undergrad research as well. So did you initially think to focus on, you said machine translation and did you kind of consider sticking with research before eventually winding up in industry?
I did. I did think about PhD, and that was something that I was a little bit sad at the end of in my senior year, because nobody in my family went to college. I didn't know what a PhD was, so I never thought about it. But only until my senior year that I got to know friends like you who was doing PhD, and I'm like, wow, PhD students are really cool. I wanted to do PhD, but by then it was too late to prepare for PhD applications. So I was thinking, let's work for a year. So I did talk to some of my advisors, and they did tell me just the same. So I joined NVIDIA. But then that's when I was realized that there were also a lot of interesting problems in the industry. So I never came back to PhD.
Yeah, well, maybe one day you will, you never know.
You never know. That's what I want to do. Like one day to get really rich and just like pursue various PhD in my free time.
Yeah, just start your own lab. You don't need a PhD at that point. So speaking of that, you went to NVIDIA, and I would assume that's kind of around when you started to hone in on this focus and specialization on machine learning systems, which is now kind of what you are teaching, and then I wrote a book about. So that's kind of your main focus, right?
Yeah, so that was I realized how small the model part is part of the whole system, because it was so much more work surrounding the modeling. And I felt like at that time there was a lot of focus on the modeling part, which is also like very important, but it's just not the only things that we can't just like only look at the modeling part.
Exactly. And just to expand on that a bit, I guess, for anyone listening who hasn't taken classes or, gone too much into AI, modeling is like, you make the AI that translates A to C, just a bit of code that does this one thing. And so, you can do that. You can do a machine learning model, train it with data, blah, blah, blah. But what you write about and teach is that, okay, you have this piece that you train to do something, but maybe counterintuitively, there's a lot more work besides doing that when you want to actually deploy it in industry.
Yeah, like data engineering, deployment, post-deployment monitoring, and continual learning. Yeah, like a lot of we also had involved different stakeholders, product people, ops engineers. So a lot of them don't necessarily speak the same language as the machine learning engineers or data scientists. Also, like subject matter experts as well, like for labeling or even like curating the predictions, like post-processing of predictions. For example, like if you work on Stitch Fix, you might make a lot of recommendation for items, because you might want to involve some stylists to like look over them and like rank them again. So you need to have like an interface for non-engineers or non-data scientists to get involved into the systems and make changes as needed.
Mm-hmm. Exactly, which is not a consideration at all in research. Yeah, but this reminds me, in your book, which we'll talk about in more detail soon, you do early on have a bit on industry versus research when it comes to machine learning, and really contrasting a lot of how these two compare and how they're actually very different in a lot of ways. So for any listeners who might be on the industry side or on the research side, maybe could you just walk through what your comparison was for that?
So one thing is like in research, right, we focus a lot on training because you need to train models multiple times, and you probably do inference like once, like for test, like validations or testing. So people like a lot of time they optimize for like fast, like high throughput of like training data. But in productions, we want to optimize for inference, especially if you do online predictions. So you have to care about like latency, which a concept a lot of researchers don't really care about. Another is very important is the metrics. So I think in research, we a lot of time we focus on one specific metrics. For example, like if translations and something like blue score, something or if other tasks, then maybe like I don't know, F1s or accuracy. So performance metrics is not everything. Like in productions, you care about other things as well. Like latency is just one thing, but also like interpretability, like fairness. So one thing I like to ask my students is that you give them like different models, but like one model has very good like high overall performance, and the other model maybe like not so well. But then like have, for example, like you have model A with 98% overall accuracy, but then they make like is for the majority users, they have the 99% accuracy, but for minority, it's only 80%. And then another models, that's like maybe 95% accuracy, but they perform equally well for both majority and minorities. And which model would you select? So there are a lot more considerations in deploying models that a lot of research benchmarks don't necessarily capture, but I also know that it's changing. I think there have been more and more research papers talking about maybe more dynamic leaderboard to have more metrics that we care about, and not just like pure models accuracy metrics.
Yeah, not a single number that you can increase to get state of the art and say we achieved SOTA on this in this benchmark.
Yeah.
Okay, well, yeah, apparently research is different from industry in that you actually need to build something that works.
And it should be, right? Like, I think like research have different goal, and I guess industry have different goals. So I think it's normal to have different things. So another example was that I just like forgot is very big is data. So I think that's something that I feel like one of the biggest problem is in research we work a lot with static data. And it should be, because like it wants, like if you develop a model and I develop another model, we want to be able to benchmark against the same data set to say like which one actually make an improvement. So data sets in research are like usually very well studied. People know on the quirks, like, okay, if you have this data set, you need to like remove this kind of weird character or something. People know, understand data set. But in productions, data is like ever changing. So you develop a model, data distribution shift is something I think that happen a lot in productions. And I think the research also like study a lot. But so when I was writing my book, I did look into like data distribution shift, and I realized that research and industry have actually quite different vocabulary. So people like have multiple different terms for the same thing, like concept drift, label shift, covariance shift. There are a lot. I actually don't remember everything off the top of my head. So a lot of time in research, we saw the paper, but they make a lot of like unrealistic expectations, assumptions. For example, like to address distribution shift. So like when you the data today differs from the data yesterday, and you so like if you train the model on data from yesterday, so it won't perform very well on data from today. So you want to adapt the model to data from today, right? So the model, so like a lot of research assumes that we know in advance what the future distributions are going to be like. so you can adapt the model to that. But a lot of time we want to adapt the model before we know the shift. Does it make sense? So we want to build the model robust enough, because like when the shift happened and we haven't, so we don't know the shift before the shift happened.
Of course, yeah. So makes sense. Yeah, it's interesting. And it's interesting that that's the case, that there's this disconnect, given that these days a lot of industry is just former researchers. A lot of industry engineers seem to be, former grad students in AI. And some companies like Google, like, just have a ton of engineers and a ton of researchers. In some cases,
hard to compete with them.
Yeah.
I see a lot of like AI researchers are affiliated with companies, I guess, for a good reason. There's another is that it can be like pretty hard for researchers to do certain kind of research. For example, for recommender systems, right? Like if the model makes the recommendations, you want to evaluate its performance by seeing like whether a recommendation is clicked on or is selected by a user. So it requires certain interactivity that you don't really have, you can't have with a static data set. So we have a lot of like researchers come to us. It's like, yes, we want to study that, for example, in the context of like conditional bandit, but then they just don't have interactive data or like an environment or simulations to actually study the algorithm.
I see. Cool. And also, I hear this all of the time, and so I wonder if you would agree. The common wisdom is that in research, you care about having like the latest and greatest, sexy model that does all the cool stuff. And then in industry, you just want like a simple model that you can throw all your data at. And the best thing is not to improve your model, but just to get more data, right?
I think the industry want sexy models as well. It's just like sometimes sexy models are just not feasible because they might cost way too much money. So a lot of times, so I think like, for example, like I was talking to some infrastructure engineers, right? And they tell us like, when you evaluate tools, that choose a tool that's like well understood, have a lot of community, so that if something breaks, you know how to fix it. And a lot of time, it's very similar for machine learning models. In the industry, you might want to choose a model that's like well known, well understood, and been highly optimized to run on different like hardware that you want to run the models on. So if you choose like sexy new models, then it hasn't been tested. No one has optimized it. NVIDIA hasn't thrown 10 engineers at it to make it like super fast on GPU. So you probably don't want to use it. Yes, but companies do. Like a lot of companies fall for the soda trap and comes like, hey, we want to use this like super cool model. How do we do it? And we're just like, okay, if I don't need, you probably need a logistic regression. It happens. But companies do want that.
Yeah, that makes sense. Okay, and now I guess you've been in industry for like 4 or 5 years. So yeah,
don't tell people that.
You've been out in the real world for
a long time.
For a long time, yes, for a long time. And yeah, it's interesting that you got into it around 2014 at the top of the hype cycle. And you went to the industry in a few years ago. So how do you think the perception of AI is in industry now? Like, have people calmed down and have a more grounded understanding of it as far as what they're pursuing? Or are we still not at kind of the bottom of a hype wave?
I think we are in the maturing stage. So I think with a lot of like any new things, there are like certain consolidations, and where we see the consolidations, what happens with research. Like research has become pretty expensive nowadays. It's like where we see several major labs pushing out large models. So there's a lot of consolidations, and I could see the same things is happening in industry. It's just like a little bit behind. So one thing is that like I think we are in the maturing stage for ML ops or ML productions. So what that means is that now, before we didn't know the challenges. So I think like I did before. So like a lot of companies started adopting machine learning maybe like 4 or 5 years ago, and at that time they built their machine learning platforms for the need they thought back then without a lot of understanding of like the challenges. So we've seen a lot of companies coming to us and saying, hey, we realize that now we can't address the complexity of today's workflow. So we are in the process of re-architecturing our platform. So we understand a lot more about the challenges. So we know that like, okay, data-driven shift, like monitoring is super hard. Continuous learning is inevitable. So like online predictions is very important. We can't just like do batch predictions anymore. Of course, we can still do that for a lot of tasks, but for many tasks like recommender systems, for detections, customer support, you can't just do batch prediction anymore. So online prediction is very high on the list. So we need to like build out our infrastructure to solve these challenges. And we also know that data scientists can't be expected to solve these problems because data scientists are good at a lot of things, but we can't reasonably expect data scientists to be good at both data science and infrastructure. So we need to invest more in infrastructure. So company knows that. The unknown though is still like what is the right architecture. So I think the community is still in debate over that.
Yeah, that makes sense. Yeah, and I guess that really brings kind of makes clear that another interesting aspect is this whole notion of machine learning infrastructure, AI infrastructure, where again things move so quick that when you were in an undergrad, when I was in my master's, I don't know, even I guess some big companies had infrastructure, but it was very, very young, right? So as you said, it probably matured. And in fact, this reminded me in 2020, you wrote a blog post called "What I Learned from Looking at 200 Machine Learning Tools."
Yeah, was painful.
Yes. So, and you looked at a bit of a history of how it was kind of the landscape was happening and problems facing ML ops and some stuff. So what were your impressions from writing a blog post back then? And do you think things have changed in the 2 years since you wrote that?
Yeah, one thing is just like a lot more companies have emerged. A lot. So I think like when I first wrote the post, I was trying very hard to categorize the tool. I think it could be one of the reasons why people like the post was that I think it was the first. I feel like maybe I'm not sure it was actually the first, but it could be just for a lot of people, or for me at least. It was a very first attempt to like, okay, I didn't want to say very first because no one can be the first at anything. But yes, but I think I did try to categorize them tools in different categories. And I think that over the last 2 years, some of the categories have matured a lot. So categories like experiment tracking, so have certainly matured. So there's a category of like deployment tools that has like matured a lot, but it's not entirely mature because a lot of deployment tools focus on batch deployments and not really highly optimized for latency, online predictions. And also like there's certain new categories like feature store. It's pretty new since the last 3 years, 2 years. I think back 2 years ago, it was like not very well understood. But now a lot of companies looking into them. So a lot more have emerged. So I think we have better understanding of like what kind of tools there are, what stages of the production cycle looks like. Oh, and there's a whole new category of tools that was really funny. So because the landscape nowadays, it exists so many different categories and it's so fragmented, there's a new category of tools that emerge just to glue different tools together. So they call them like interoperability, something like that.
Interoperability. Yes. That's a hard word to say. Interoperability. Yes. That's interesting. I wouldn't have thought that. And again, for this stuff that we're discussing, for blog posts, as usual, we'll include links in the description, or you can just look up Chip's website.
So I think that one thing that I learned from that was that it's very confusing for customers. Mm-hmm. Because I was looking into it, I felt like I have some understanding of like the ML landscape, like what it does, and I still had a hard time understand a lot of what these tools do. I think like one reason I wanted to like people use very generic term. Everyone's like, oh yeah, we are like a platform. We do this amazing. We reduce speed by like from days to minutes. Like it doesn't really mean anything. Or like a lot of time people like invent the new phrase to describe them to try to make themselves stand out from other tools. And then we have a lot of like it's just impossible to understand. So it's just like recently we have an event on our Discord, and for our event, the best part actually is the after party. So it's when it's not recorded and people start talking like their honest opinion.
Don't record your fun Discord chat.
So I think like I have this theory that like purchase like ML adoptions, like companies, business leaders make decisions not based on merit, but based on hype. So like a lot of time, like it was like here because a company got a lot of VC money and they just like blast all over the place. Like people said like when my friends when they got Instagram, they get like advertisements for for like jewelry or for dresses or like whatever for food. I just get a lot of advertisements on like the new ML tool. That's my Instagram.
You get ads from a new AI infrastructure tools?
Yeah, on the new AI conference. It's like there's so many of them.
Oh, conferences. Okay. Fair enough.
So like solar companies, they have a lot of like VC money and they start like paying a lot of money for marketing. And then like a company says like a business leader say, okay, a lot of people are talking about this. Do we need to jump on this trend or are we missing out? So it just seemed to me like it's very hype based. But the same, I think just gonna change. I think slowly, I think we see that more over time. We have more winners emerge, and the purchase decisions are less hype based and more fact based. Okay, but please, if any business leader is listening to this, I'm not trash talking anyone. It's just
broad terms. I mean, I think it's fair to be a bit cynical. As an adult, a lot of people make a lot of decisions without being entirely informed. And so after working at a few companies, NVIDIA, Snorkel AI, Netflix, and learning about this ecosystem and all the tools and so on, you have co-founded Claypot AI, your own company, creating a new tool of some sort, as I understand it. So, yeah, how did that come about? Did you just sort of realize that there's a thing that doesn't exist that needs to exist, and then like I'll do that?
Yeah, I hope so. I think the idea was like stuck with me for a while. I did see. So the original idea was that I saw something like mesmerizing about TikTok. It was just like, how are they able to like adapt the preference so fast? So I was talking, and it was at the same time because I was working at NVIDIA before, so we did have some customers, Snorkel as well, and we just really think it's like pretty okay. No offense to anyone, I think it's a general observation. It's that deployment was still very hard, and I was like, okay, for certain companies, it takes them like months to update a model. How can TikTok do that so fast? So I started talking to people at ByteDance. And then I talked to people at Alibaba, Tencent, at the same time I talked to a lot of other companies in the US. And I saw like a stark difference. Because like some companies just move really fast. Like Weibo, as a first generation of ML platforms, they like retrain the model like every month. And now it's the sixth version of the ML platforms. They can just update the models like every 5 to 10 minutes. And it is not small model, it's a large model. And it was like, what is the technology? Like, what is the secret? And they start talking, and there's something called like real-time data or a near real-time data, like streaming technology. So I mean, as a machine learning engineer / data scientist, of course, I didn't really understand that. So I was talking to my friends, was like, who's the best person to talk to about streaming? And they were very kind. They pointed me to a lot of people. And there was one person that I had like really great rapport with. He was leading the streaming team, data platform team at Netflix. So he was very helpful. He was very patient explaining to me because I was like pretty stupid back then with the streaming. But then I learned a ton from talking with him. And then over time, we kept in touch. Like we talk like every 2 months, and then we realized it's like there are a lot more problems. So we started talking like every month, and then every 2 weeks, and then he finally decided to leave Netflix, and that's how we started the company together. But the goal is like to make it like it's very easy for companies to do fast iterations of their machine learning models, both for predictions and for continual learning.
Mm-hmm. Yeah, and this is generally describing this notion of real-time machine learning, which I think is something pretty novel. You don't get taught that in undergrad, right? Or even in grad school. Yeah. Yes. Well, I guess you'll be teaching it. So
I think it's really cool. I think a lot of companies already leverage like some sort of streaming for like logging, like notifications. They just haven't adapted that for machine learning. So the reason is that streaming is owned by distributed systems, and things are pretty complicated when you do things at scale. Because with streaming, right? Because you have like continuously incoming stream of data. So if you just have slow to process at some point, even cascading to the future. So it's pretty like one other factor that is hard. And a lot of data scientists are not familiar with streaming, and so I think you see that it is hard. I think we talked to a lot of data scientists and just terrified by touching distributed systems.
Yeah.
So yeah,
those are scary. I would be scared.
I was scared. That's why I was like, okay, my co-founder, he just does everything.
Okay.
I'm just like
I see. You're just the brains.
No, he's a brain. I'm the math. I'm the talker.
Oh, okay.
I'm just kidding. We both do things.
Of course.
No, I think that's a nice thing to talk about having a co-founder is that it makes your life a lot easier, like a lot, because I was working on this idea before I met him, but saying like real-time machine learning is fundamentally a infrastructure problem. So that's not a problem that I can solve easily. So the nice thing about having a co-founder who has skill complementary to you is that you both do things, but then you split work 50-50, but then the part that he does is like really, really hard for you to do.
Is the part that you would do way more slowly. Yeah.
Yeah. So like he doesn't come from a machine learning background, right? So I think of course about like the more, but I think that it works out nicely. And I think that there's something that our investor did say, a reason, because it's a lot of teams that have very homogeneous background and the same skill set, but we did have pretty wide coverage as a combination of our skill set.
Oh, okay. Yeah, that's cool. And then, I guess on that note, it's worth noting that as far as your skill sets go, we've touched on this a bit, but not only are you an expert in AI, or an expert now, not so much a so-called expert, but you do also like to write a lot. So we've talked about some of your blog posts. And now is the time to get to your new book and class. So you have a class called Machine Learning System Design, and then a book called Designing Machine Learning Systems. Yeah. How did those two come about?
So the book is based on the lecture note. So I think for me, I think this is something we written for a long time. I think I had a booklet on machine learning system design, I think back in 2019. And then that evolved into a course, and the course went through like a couple iterations. So got a lot of feedback and a lot of thoughts went into this. So the book is more like the result of a pretty long process, 3-year process. Wow. A lot of feedback, yeah.
I see, yeah. A lot of people listening to this are probably engineers or AI researchers, etc. Would you say writing a book is hard?
Everything worth doing is hard. I was talking with friends this weekend. It was just like everything we brought up, it's hard. Building a community is hard. Building a platform is hard. Writing a book is hard. Doing a PhD is hard, right? I think everything worth doing is hard.
What was the process of writing? But did you learn a lot as you went about kind of forming this book?
A lot. I think he has gone through so many iterations. I'm a big fan of iterations, like very big. It is cynical machine learning models. Iteration is everything. So like somebody on the internet once said, it's like the best way to get the right answer is to say the wrong thing and wait for it to correct you. So I think that's my approach to writing. It's like I just need to put my thoughts out there and just ask people who know better than me to look at it and be like, okay, this is just wrong. And so that's why I get a lot of feedback.
I see.
So a lot of time through the process. Like a lot of people say, okay, this doesn't sound right. I was like, okay, why is this way? I'm like, or they might point me to like related resources, or they might retell, or they might be, oh, I totally agree with this. And then they start telling me a story of like how they encounter that, which makes it a lot more concrete. So it was really awesome.
Oh, okay. That's good to know. And then, now it came out. It came out, what, like a week or two ago, right?
Yes. I think when was that? A week ago. It feels like forever ago. Yeah.
Yeah, a long time ago, a week ago. So, if you're listening, you can already order it. It's been doing pretty well, and I think people seem to like it. For whom did you write this book? Who would you say should consider look into getting it? And kind of broadly, what are the contents? What will you learn about from looking into designing machine learning systems?
So I think it's for anyone who is interested in working with machine learning systems in production. So it's not much about research. We don't really covering like different types of architecture, like what's the difference between like convolutions and recurrent. We don't do that. Like I don't do that in the book, but mostly for people interested in like building a production ready system.
Okay, so there you go. If you're in industry, consider getting a book. And I think with that, we'll close out. Thank you again, Chip, for joining us for this interview.
Thank you so much for having me. I hope that you can understand me. I know I got very excited and spoke very fast. So, yeah.
Well, I could. So if the listeners can't, then that's on them.
But you also have known me for a long time, Andre. If by now you still
understand me. That's not a fair bar.
Yeah. Unfriend you now.
Okay. Well, hopefully people understood it. I think they did. And this was really fun. So thanks again for having this chat.
Thank you so much for having me.
And just to close out, once again, this is a Gradient podcast associated with the Gradient magazine over at thegradient.pub, where we have a lot of text articles about AI. Feel free to check it out if you have not. If you've enjoyed this interview, please do subscribe to the podcast if you haven't. It's available everywhere. And if you're subscribed, then maybe share this with your friends or other people interested in AI, or even go ahead and review it on Apple Podcasts, where we do not have that many reviews. We'd love to hear your feedback. But all that aside, the main thing is please do keep tuning in. We're going to have a lot of interesting interviews coming up. So keep listening, and thank you for listening to this one.